is Fusion 316 Reconstruction dataset really not enough for training when compared with DeepCAD dataset. The abstract is as follows. This paper seriously investigates the two typical datasets in CAD sequence learning. The DeepCAD paper indicates that the limited size of the Fusion 360 dataset is insufficient for training a well-generalized model. However, this investigation reveals that although there is a huge gap in datasets between Fusion 360 Reconstruction dataset and the DeepCAD dataset, they have almost the same ability in CAD sequence learning. The contributions are as follows. First, this paper is the first one that seriously investigates and verifies the dataset problems in CAD sequence learning. Second, we carefully devised 6 reasonable experiments to demonstrate that two datasets are essentially indistinguishable and exhibit equivalent capabilities in CAD sequence learning for typical sketch and extrusion commands. Third, we propose a novel data augmentation method for CAD sequence, namely RSEI data augmentation. To ensure consistency with the DeepCAD dataset in terms of limitations and entity types, we select 7,062 samples from Fusion 360 Reconstruction dataset. We analyzed two datasets and found that Fusion 360 Reconstruction dataset contains more longer sequence length and extrusion count than those of DeepCAD dataset. The RSEI augmentation method involves these steps: sequence pre-checking, determine the number of bodies, determine the indentation position, generate the new sketch, execute the new sketch, concatenate all new sequences, and validate the feasibility with CATIA. The red set is an example. We conduct experiments on 3 typical tasks in CAD sequence learning: sequence reconstruction, sequence generation, and LLM-based text-to-CAD. To ensure a fair comparison, all networks trained in the above experiments are evaluated on the same test set, in which the partitions of the DeepCAD dataset and the Fusion 316 Reconstruction dataset are equal. Through the following tables, both datasets with 7,062 samples or 178,238 samples exhibit similar ability for CAD sequence reconstruction task. Also, both datasets exhibit similar ability for CAD sequence generation and LLM-based text-to-CAD task. Finally, we conduct cross-dataset evaluation on the OMI-CAD dataset for both the sequence reconstruction and sequence generation tasks to verify the dataset saturation. Based on the following experiments, we conclude that widely used CAD datasets currently face data saturation issues for CAD reconstruction and generation tasks. This paper systematically investigates and compares two widely cited CAD datasets in CAD sequence learning: DeepCAD dataset and Fusion 360 Reconstruction dataset. Through 6 experiments and a data augmentation method, we demonstrated that the two datasets are essentially equivalent in supporting CAD sequence learning tasks. In short, this investigation provides an interesting insight that widely used CAD datasets currently face data saturation issues for sequence reconstruction and generation tasks. To further advance the development of CAD sequence learning to support real-world design processes beyond the sketch and execution commands, We need more complex and advanced city datasets, which is a more challenging task for our community in the future.